Imagine being able to float in midair, defying the pull of gravity. This isn't just the stuff of science fiction, it's the fascinating world of anti-gravity. What if I told you that there's a concept which, if harnessed, could completely revolutionize our understanding of the physical world? This concept is known as anti-gravity, a hypothetical phenomenon that counteracts the force of gravity. It's like a mirror image of gravity, pushing objects away instead of pulling them in. You've probably encountered this idea in popular culture. It's a favorite of science fiction writers and filmmakers, who often use it to explain how their characters can travel through space at incredible speeds, or hover in midair on futuristic skateboards. But the concept of anti-gravity isn't just a convenient plot device for sci-fi narratives. If it were to be realized, it would have profound implications for the real world, particularly in the fields of space travel and transportation. Imagine a world where airplanes and rockets don't need to expend massive amounts of fuel to overcome the Earth's gravitational pull, or where we can transport goods and people from one place to another without the need for roads or rails. These are just some of the potential applications of anti-gravity. But before we get carried away, it's important to note that anti-gravity remains largely theoretical. Scientists are still trying to figure out if it's even possible and how it could work. The laws of physics as we currently understand them don't allow for anti-gravity, at least not in the straightforward way it's often depicted in fiction. But that doesn't mean we can't explore the concept. And who knows? Someday we might even find a way to make it a reality. So hold on to your seats as we delve into the captivating world of anti-gravity. To understand anti-gravity, first we need to grasp what gravity is. Picture this: you're holding a ball in your hand. You let it go, and what happens? It falls to the ground. Why does it fall? That's gravity at work. It's a force that pulls objects toward each other. The Earth, being quite a large object, has a strong gravitational pull, which is why that ball falls to the ground instead of floating away. Gravity is an invisible force that impacts everything around us. It's why we stay firmly planted on the ground instead of floating off into space. It's why the Earth orbits the sun. It's why the tides ebb and flow. Even light, which has no mass, is affected by gravity. Now imagine if we could reverse gravity. Instead of pulling things together, it pushes them apart. This is the basic concept of anti-gravity. It's a hypothetical force that goes against the natural pull of gravity, causing objects to repel each other or float freely in space. But here's the catch. As of today, anti-gravity only exists in science fiction and theoretical physics. We have yet to discover a real-world application or evidence of anti-gravity. But that doesn't stop us from dreaming and exploring the possibilities. Now that we know what gravity is, let's flip the script and explore anti-gravity. Anti-gravity might sound like a concept straight out of a sci-fi movie, but it's something scientists have been trying to understand and achieve. The pursuit of this seemingly impossible phenomenon has led to intriguing experiments and discoveries. Consider magnetic levitation, for instance. It's a compelling demonstration of anti-gravity at work. By exploiting the repelling force between like poles of magnets, certain objects can be made to levitate, literally defying gravity. It's a fascinating spectacle to behold, and it's the principle behind high-speed maglev trains. Then there's the wonder of superconductivity. When certain materials are cooled to extremely low temperatures, they can conduct electricity with zero resistance. This phenomenon allows for a type of magnetic levitation known as quantum locking, where a superconductor can be locked in space above a magnetic field, seemingly suspended in thin air. However, these advancements have not come without challenges. The need for extreme temperatures for superconductivity, for instance, limits its practical applications. But these obstacles don't discourage our scientists. They inspire them. Imagine the possibilities if we could truly harness anti-gravity. It could revolutionize space travel, making journeys to distant galaxies a reality. It could lead to more efficient transportation systems, reducing our reliance on fossil fuels. The potential breakthroughs are as endless as they are exhilarating. While we're still a long way from floating cars and anti-gravity boots, the quest to understand and harness anti-gravity continues to push the boundaries of our knowledge and imagination. It's been an incredible journey exploring the enigmatic world of anti-gravity. We've demystified its concept, delved into potential applications, and brought you up to speed on current research. From its theoretical basis to the exciting possibilities it holds for future technologies, anti-gravity continues to captivate scientists and dreamers alike. As we close this chapter, let's not forget that science is an ever-evolving story. Remember, The future is not set in stone, and who knows, the world of tomorrow may be a place where gravity is just an option.